In this problem, we're going to have to figure out empirical formula first, and then figure out what the molecular formula is. All right, so nicotine is 74.0% carbon, 8.65% hydrogen, and 17.35% nitrogen. All right, what's the empirical formula? The steps for figuring out empirical formula are, what's the first step?
Convert the percentage into grams.
Good. Percent to grams. Now, what do we assume? Tina, you remember?
That is 100.
Yeah, it's 100 grams, right? Because if we have 100 grams of this, instead of it being 74.0%, it's going to just be 74.0 grams of carbon. So they're all just going to convert right over from percent into grams. All right? What was the second step? Grams to what? Exactly, grams to moles. Because it's the mole chapter, right? Good guess if you don't know what to do, just convert it to moles. All right, after we have moles, what was the next thing?
Divide by the smallest.
Yeah, good. Divide by the smallest number. Because we want to keep the ratios the same, so we're going to divide everything by the same. And then the fourth one, this only happens sometimes. You might have to do this one. Does anyone remember what this was? Yeah, Dina? Good. Multiply by some kind of integer. Got to be a positive whole number. All right, and that's in case we have a fraction. That's to make it not be a fraction anymore. All right, so that's the sometimes. Okay, let's go through this. 74.0 grams of carbon. We're going to convert that into moles of carbon. All right, we're also going to have to do the same thing for hydrogen. And the bottom number is grams, and then we get that from the periodic table. It's 1.01 grams of hydrogen. 1 mole of hydrogen. And the last one, 17.35 grams of nitrogen, 14.01 grams of nitrogen mole. Okay, so once we plug it into the calculator, we'll get these numbers here. So we, there's 4 sig figs for some reason with this last one, so that's why I left it with 4 sig figs. The next step is number 3, so we're going to divide by the smallest number, which is going to be this N one right here, the nitrogen. Now you can just do it right here. You can just draw lines and then write the numbers. You don't have to write it out like C, H, and then N and put the numbers in here and then divide it. I'm going to put the numbers in after I do this small division, just because then there's less writing over there. And doing these problems takes a lot of time. So this is kind of a shortcut, but you're still showing all the work because you're showing the divide by the smallest. All right. So when we divide by the smallest, N is 1. Carbon is going to be 4.97. H is going to be, what is that, 6.91? And then N is going to be 1. All right. Now, this is an interesting problem because they're not any of the multiples. We can't multiply these by anything. You don't multiply it by 100 because that would make a huge molecule. We don't multiply it by that. But they're also not close to anything we talked about before, which was like 0.25, 0.5, 0.75, or 0.33 or 0.66. They're not near any of those, right? So when you get this kind of a situation, you can actually round it to a whole number, which makes it a little easier. They're pretty close. 4.97 is very close. This a little bit further, but still, if it doesn't fall into one of these 5 options, you're going to have to round it, all right? So our answer would just be C5H7N. And the reason that it might not be perfect is maybe these numbers aren't really that perfect. They only go to 3 sig figs. Maybe they need more sig figs. All right, but then this would be our empirical formula. All right, this would be our empirical formula here. Next part is this. First step, we need the molecular mass of this, all right? So one, we're gonna figure that out. C5H7N, all right? So carbon, we know, 12.01 times 5, plus hydrogen's 1.01 times 7, plus nitrogen's 14.01. Alright, so when we add all of that up, we'll get our molecular mass, which is 81.13. And I put it on the bottom because that's where the empirical formula goes. Empirical formula goes on the bottom, the molecular mass of it. And then on the top is the molar mass of the whole molecule. All right, so that's the 162 grams per mole. Now in this case, it also becomes 2. It's not always going to be 2. It's just a coincidence that our two examples give us 2. All right. Once we have the 2, what do? Yeah, exactly. We multiply it by the empirical formula from up here. C5H7N. All right, so that's going to make this now C10. H14 N2. And that's going to be our molecular formula. Okay, so we figured out empirical formula. We figured out molecular formula by doing all of these steps. Any questions with that? Yes, got it.
Why don't you use grams per mole instead of grams? Like when you use either one?
Oh, like here we used grams, and then here we use grams per mole? Good question. In a way, you're always using grams per mole, all right? Because it's grams per mole, right? This is the molecular mass off the periodic table, grams per mole. We're just writing it this way because it's fitting into our equation like this. Down here, this is the same thing, 62 grams per mole. If we were going to do like a conversion, that 162 would be here, and then it would be grams per mole, all right? Or you could flip it upside down and have the 162 grams per mole as well. So you can flip it either way, all right, depending on what you need, all right? So we didn't get rid of the grams per mole part. It's just, it looks a little different depending on what you're doing, all right? Any other questions?